Quadratic inequalities. These are surprisingly useful. Very often in the real world, we're interested in ranges of values where particular conditions are met. And quadratic inequalities are an introduction to this that's just a step above the linear inequalities you'll have dealt with in ordinary maths. So we want to solve the quadratic inequality x squared plus x minus 12 is less than 0. So start by considering the equation. So we're going to consider x squared plus x minus 12 is equal to 0. If we want to factorize this, we want numbers that multiply to give negative 12 and add to give positive 1. So 4 and negative 3 would do this. Because this is a monic quadratic, we can go straight away to brackets. X plus 4, x minus 3 is equal to 0. So x plus 4 is equal to 0, or x minus 3 is equal to 0, giving us that x is equal to negative 4, or 3. Now think about this quadratic function. If we were to sketch it, the information that we have so far tells us that the x-intercepts are at negative 4 and at 3. Because the x squared term is positive, I know that it's going to be a happy curve. In other words, it's going to be a quadratic that's shaped like this. So this is y is equal to x squared plus x minus 12. If we're after less than 0, that's where the curve is below the x-axis. And I can see that it's below the x-axis if x is more than negative 4 and less than 3. Now, at this stage, you haven't done much curve sketching. That's coming slightly later in the course. So, could we have done this from here without sketching the curve? Well, yes, we could have done. Having these two solutions gives us some different regions. We can look at when x is less than negative 4. We can look at x being between negative 4 and 3. And we can look at x being more than 3. So consider the function x plus 4 and the function x minus 3, which together make up our function. If x is less than negative 4, say negative 5, this one is negative, and so is this one, negative 5 take away 3. If we're in between here, say x is 0, this one would be 4, so that's positive, and this one would be negative 3, so that's negative. And for more than 3, let's take 4. This would be 4 plus 4 is 8, so that's positive. This would be 4 take 3, which is 1, so that's positive. And we multiplied them. Negative times a negative gives us a positive. Positive times a negative gives a negative. Positive times positive gives positive. So we're after this region here, so that it's less than 0, i.e. negative. Now for this one, just like solving an equation, bring everything to one side. So we've got x squared. I need to subtract 3x from both sides, so that will give me minus 2x. And I need to add 4 to both sides, so that will give me minus 8 is less than or equal to 0. And then consider solving x squared minus 2x minus 8 is equal to 0. So we want numbers that multiply to negative 8 and add to negative 2. So if we have negative 4 and 2, that would do that. So I have x minus 4 and x plus 2 is equal to 0. And that would give me that x minus 4 is equal to 0, or x plus 2 is equal to 0. So x is equal to 4, or x is equal to negative 2. Now we'll do this via table because, as I mentioned, the graph drawing comes later in the course, but I did that with the first example so that you could apply that method later on when you've really done a lot more curve sketching. So let's think about the regions that this opens up. So the smaller solution is negative 2, so we could look at what happens to the left of negative 2. We'd want to look in between, so in between negative 2 and 4, and what happens to the right of 4. And the two functions that make this up are x minus 4 and x plus 2, and we multiply them together. You could do this in one step just by looking at the quadratic that we have here and seeing what happens to that. So if we take a value less than negative 2, like negative 3, this one would be negative, this one would be negative, and since we're multiplying them, the result would be negative. Sorry, positive. Negative times the negative. If we take a value between here, such as 0, this one would be negative, but this one would be positive, so overall negative. And greater than 4, say 5. 5 take away 4 is 1, so that one's positive. And 5 plus 2 is 7, so this one's positive, so multiply them, and it's positive. So it's negative in the region between. We wanted less than or equal to. So this time, we're going to have less than or equals to, rather than just less than signs. And x is between negative 2 and 4, but this time including both negative 2 and 4. Solve the quadratic inequality 15 plus 7x minus 2x squared is less than 0. Now, what I might do with this one is just take everything to the other side, because I like dealing with my quadratics with a positive coefficient for x squared. So if we add 2x squared to both sides, we've got 15 plus 7x is less than 2x squared. And then you can see what's going to happen. I'm going to subtract 7x and subtract 15 from both sides. So we get 0 is less than 2x squared minus 7x minus 15. And I'm going to write that the other way round. 2x squared minus 7x minus 15. Make sure the crocodile's mouth faces the same thing. So that's greater than 0. And then I want to consider 2x squared minus 7x minus 15 is equal to 0. So we need to factorize here. We're looking for numbers that multiply to give 2 times negative 15, so it's negative 30. And that will add to give us negative 7. And that looks like 10 and 3, with 10 being the negative because we want negative 7. So I've got 2x squared, and then split the negative 7x to negative 10x plus 3x, take away 15, and factorize each half, so that's 2x, x minus 5, and 3x minus 5. So that gives us 2x plus 3, x minus 5 is equal to 0. So 2x plus 3 is equal to 0, or x minus 5 is equal to 0. So this one would give us x is negative 3 over 2. This one gives us x is 5. So that opens up regions for us. So we can look at x to the left of negative 3 over 2. We can look at x between negative 3 over 2 and 5. And we can look at x that's more than 5. And we'll consider the factors 2x plus 3 and x minus 5. And then we'll see what happens overall. So, if we go to the left, say go to negative 2, this would be negative, this would be negative. They're both negative. Multiply them and we get positive. In between here, say 0, this one's positive, this one's negative. So overall we get negative. And greater than 5, say 6, they're both positive. So we end up with a positive. And in this case, we're after where it's positive. Now it's two different regions, so you need to give it as two different inequalities. So x is less than negative 3 over 2, or x is greater than 5. And you can apply all sorts of set notation to that if you want to, but that will suffice for now. It's two separate regions. If we graphed it, we're after where it's above the axis, so it's from here this way, where this is 5, and from here this way. So its separate regions give separate inequalities.